All right, in this short video, I want to address competency 6. If the system has infinitely many solutions, specify the set of solutions in terms of free variables. Okay, so that's going to be here. I'm going to say use free variables. Oops, let's go ahead and draw and type. Say, go here and say use free variables to specify solution of when infinite number of solutions. All right, so let's give some examples. All right, so suppose my REF looks like this. Okay, I'll have 1, 0, 0, 5, 4, 3, and then you'll have 0, 1, 0, 2, 2, 9, and then here I'll have 0, 0, 1, 4, 4, minus 3, and then here I'll just throw in this for jollies, 0, 0, 0, 0. All right? Now, this is already a form, so let's interpret this. This is my first variable, x1, x2, x3, x4, x5, and then this is the constant column. Now, all you have to do is write this out in equation form. I have 1x1 plus 5x4 plus 4x5 is equal to 3. Then I have 1x2 plus 2x4 plus 2x5 is equal to 9. Then I have 1x3 plus 4x4 plus 4x5 is equal to minus 3. All right, so I've got these equations here. So here we can say this is pivot, pivot, pivot. And then these are non-pivots or free. Now what you want to do when you have something like this is move the free variables to the right-hand side. So we rewrite in this way as x equals 3 minus 5x4 minus 4x5. Then this one, x2 is equal to 9 minus 2x4 minus 2x5. And then this one, x3, is equal to minus 3 minus 4x4 minus 4x5. Okay. So I have my basic variables and my free variables. Now often we replace the free variables with different letters like y or z, something like that, because these are arbitrary. So x4 and x5 are arbitrary. That's what it means that they're free. So I'll replace with y and z. Okay. Oh, it's not letting me go down. Okay. All right, so let's just go ahead. So I can just simply write this as x1 equals 3 minus 5y minus 4z. This one's x2 equals 9 minus 2y minus 2z. And this one is x3 is equal to minus 3 minus 4y minus 4z. I'm going to kind of jump ahead a little bit so you can see where we're going here. I could rewrite this kind of in a column form as x1, x2, x3 is equal to 3, 9, minus 3. And then here I have plus minus 5, minus 2 minus 4, this is times y, plus minus 4 minus 2 minus 4 times z. All right, now I left some space here because this gives me x1, x2, x3. And you just read this across row by row, and that gives you the different rows here. But I don't have x4 and x5. What about x4? Well, x4 was what I replaced with y. So here I'd have a 1 here, and I'd have a 0 here, and a 0 here. Then x5 would be what my z is. Okay, so I'd have a 0 here, and a 0 here, and a 1. Okay, so let's extend it down. So here's how I can write my solution, kind of in abbreviated form. And like I said, I'm jumping ahead a little bit, but we will be using this form quite a bit. So I'm thinking of this as a column of numbers, my solution variables as a column of numbers, or what we would call a vector. And this vector is equal to this column of numbers, or vector, plus any number y times this column, plus any number z times this column. Okay, so that's kind of a nice compact way of writing my general solution. Let's try one more. I'll just make one up. All right, here's the one I made up. And here's my x1, x2, x3, x4, x5, and then these are my constants. All right, let's see if we can do this a little bit more briefly. All right, this first equation is going to give me x1 plus 2x2 plus 4x5 is equal to 4. Now we know that we want to rewrite that as x1 equals 4 minus 2x2 minus 4x5. Okay, second one. Second one gives me x3 minus 3x5 is equal to 2, or x3, is equal to 2. And then here I have minus, if I bring the minus 3x5 to the other side, it becomes a plus 3x5. And I'm going to line them up like this. So this is going to be plus 3x5. Then the last one here, this gives me x4 is equal to 9. So I'll just write that this way, x4 equals 9. All right? So I'm going to replace my free variables with other variables. My free variables are x2 and x5. And I'll use, I could use y and z. Let's just use something else. I'll say u and v. That's fine. Those are called parameters. So I'm going to have equations for x1, x2, x3, x4, and x5. And I'm just going to write it this way. So I know that my x1 starts out with a 4, my x2 starts out with a 2, my x3 starts out with a 9. Okay, so we'll just start with that. Now, I also have some terms multiplied by x2, but x2 is a u, so this is going to multiply by u. So here I have a minus 2 in the first, and then I have a 0 here, and then I have a 0 here. Okay. Then last one here, I've got a v. All right, v is what I substituted for x5. So I have a minus 4 here, and a 3 here, and a 0 here. Okay. So I have my three equations for x1, x3, and x4. All right, so you see what I did. Made a mistake. This is the equation for x3 and not for x2. So I made a mistake here. I'm going to have to go back and fix this. So let's undo a bunch of stuff. Okay. So I have my start out with 4. The second equation is x3. So I want to put a 2 here. All right. First equation is for x1. This x2 has been replaced with a u. So here I have x1 equals 4 minus 2u. My equation for x3 is 2, and there's no u's at all. Okay. And then here I have a v. Last equation, this x5 has been replaced with a v, so I have minus 4v. On my x3 equation, I have 2 plus 3x5, so this is going to be a 3 here. All right. And then my x4 gives me 9 and 0 and 0. Now, what about x2? x2 is equal to u. All right, so x2 is equal to 0 plus 1u plus 0. x5 is equal to 0 plus 0 plus 1v. Okay? So I've written them this way. If this column form is confusing to you, you can just write it this way, or x1 equals 4 minus 2u minus 4v. x2 is equal to u. x3 equals 2 plus 0u plus 0v, which I'll just leave it like that. And then, 2 plus 3v. And x4 is equal to 9. And then x5 is equal to v. Okay? So now I know how to express the solution of an equation that has free variables. Okay.